one of the applications that we are going to cover today is on adaptation measure, and the another one is on mitigation measure. So the first, paper that we are covering today is about farmers, and do farmers value rice variety tolerant to droughts and floods? And there is evidence from India. So that's the first, application of discrete choice methods that we did. We did this application in India, and it's one of the adaptive measures. And I'll talk about it. How is this an adaptive measure? So this work is joint work with one of my former PhD students, Anchal Arora. She's now faculty at Indian Institute of Foreign Trade, and with Patrick Ward. Patrick Ward is now faculty at University of Florida, USA, and this project was funded by International Food Policy Research Institute. So what are we interested in, learning here, and what is this project and paper about? What does climate change do? For Indian subcontinent and South Asia, one of the impacts of climate change is to change monsoon patterns. It can delay onset of monsoon. Monsoons can recede earlier than that. There can be extreme rainfalls in certain times. So this rainfall pattern changes due to climate change. And we know that how much farmers are dependent upon rainfall. Especially in India, like over 68% of the farmers, they don't have irrigation facilities and they are dependent upon rainfall. If there is a change in rainfall pattern, that's likely to affect their productivity, yields, crops may just die, and therefore we need to think about, can there be any adaptive measures that farmers can take to protect themselves from this variability in rainfall? So that's what we're trying to find out in this paper. And the experiment we do it is with rice crop. Rice is one of the staple crops. All the population, or majority of the population in India, depends upon rice as food for alleviating hunger or to meet our food requirements. And this rainfall variability, water stress, this is another name for it, that affects rice productivity. And if productivity is low, then that affects farmers' income, their livelihood, employment opportunities, poverty. So we can see that so much of development is related to how farmers are able to cope up with the water stress that might happen due to climate change. And this variation in monsoon can result in droughts. So if there's no rainfall or delayed rainfall, there can be a situation of droughts. But we also see there are flash floods. So and Odisha is one of the states that suffers from both droughts as well as floods. So if there's too much rainfall, water is locked and your crops can be destroyed. Okay. So climate change is likely to increase frequency of these extreme weather events, and therefore we want to just study that what can be done about it. What kind of adaptive measures can be adopted, and how to protect farmers. So one of the adaptive strategy that I'm interested in here was that if there are some new seed varieties, which we are calling as stress tolerant, which can tolerate this kind of a water stress. So some seed varieties can tolerate droughts, and some seed varieties can tolerate floods, or just to explain it better, submergence. What happens is that when there are floods, the crop gets submerged in water for a longer period of time, and a normal crop will die, because if it's in water for 10 days, it'll die. But there are some new seed varieties which are called submergence tolerant varieties. They can tolerate submergence for more number of days. It's not like infinite number of days. For months, no. So maybe up to 15 days or 20 days. And these varieties are at a development stage. So a lot of investment goes in, international money goes in, billions and billions of dollars go in developing these new varieties. Everybody knows this genetic engineering and crop breeding. There are breeders, there are scientists, and therefore it's important. So the importance of the study, therefore it's important to know, do farmers even care about these attributes? What attributes farmers care about? You develop something, but if it's not even adopted, then it's a waste. So we want to inform policy and scientific body and these breeders and researchers that, okay, this is the attribute farmers value more. So maybe you should try incorporating this particular attribute. And that's where discrete choice experiments are useful. The other question would be that, why are we using a discrete choice experiment? There's so many other methods in economics. Why can't we use them? But for products for which data is not available in the market, they're not there in the market. Some varieties are released, but they're not commercially available. We don't have data. And therefore, we have to design an hypothetical experiment, which here we are calling as discrete choice experiment. And as we have already learned that these are hypothetical. So we don't have to give them actual seeds. We give them scenarios telling them that this seed can have these particular attributes, and will you be willing to adopt it? How much will you be willing to pay for it? So that's where discrete choice experiments are useful. And the other policy related question is that you may develop hundreds of technologies, but if there are no takers, the benefits are not going to be realized. So adoption is also important. Just because you develop something doesn't mean that people are going to adopt it. And related to this is, this BT cotton, maybe some of you have heard about it. These are genetically modified crops. So this is also the time when I was interested and I was doing some research in genetically modified crops that this is the most contentious topic globally. Countries have taken positions. US has taken a position that we are going to allow genetically modified crops. The major markets are, most of it is GM. Europe has taken a position that we are not going to allow genetically modified crops. And this is the time when India is thinking about, what do we do? We want to go with the world. So what India did, it allowed these in the cotton, which is called BT cotton, and over 90% of cotton which is available in India is genetically modified. It's BT, but India didn't allow it in food. So we are having this policy for both, also seeing what's there in the US and also going with Europe. Okay. So I was interested in trying to figure out. We actually did one lab experiment with Sujoy Chakravarti from CSP and Bharat Ramaswamy from ISI to find out, do consumers care about genetically modified foods? Are they willing to try them, to taste them? After doing that experiment, the next question was, what about farmers? Will they be willing to sow these kind of crops? So we went with that question in mind, and I'll tell you that why we couldn't ask genetically modified question within our experiment, and I'll tell you why, and why the focus group discussions are important. Okay, I think I'll skip some of these, otherwise I'll not complete in time. So the objective of this research was to understand what are farmers' preferences for certain attributes, and we were particularly interested in attribute drought tolerance and submergence tolerance. Okay, So we collected data through discrete choice experiment, and also we did a survey on household characteristics. As we have learned, discrete choice methods are stated preference methods where we present a series of alternatives to respondents and they have to choose one of them. And from these choices, we infer their preferences. Okay. Yeah. So, a couple of things which were, talked about in the last class also, something like consequentiality. When you're designing these experiments, you have to be careful about a few things. One, that respondents should believe that their answers have some consequences. It shouldn't be just like saying anything. So you have to convince them that these results will be presented to policymakers and maybe policies will be formed, depending upon the results from our study. So they must believe, and also the scenarios that you present to them, that should be something they can relate to. And when we did focus group discussions, we found that farmers had not even heard terms like genetically modified. So there was no point including an attribute which is genetically modified. Farmers don't even know what is GM. Okay, so I'll tell you how we framed it. We framed it differently without using that word. And another thing which I want to bring about to all these researchers here, that one has to be, whenever you're doing surveys, whenever you have human respondents, you have to be careful about ethics. So there is an ethical review committee. We have it in JNU, and it's a serious business because you can't just ask somebody anything you like to ask. You have to keep into mind that there should be honesty in what you're doing. You have to explain to the people that what the study is about, and very important, you have to take the consent. You can't force anyone to give you data and to give you an interview. So you have to take an informed consent that this is what the study is about, and do you consent to give us? And there is a whole process in JNU. I mean, it takes more than 6 months to take that approval, but it's also important and it's also a requirement. So all PhD students, if you're planning to do any kind of survey, you need to take permission from IERB. That's what it's called in JNU, Institutional Ethical Review Board. And they'll go through your proposal. They'll go through your questions. Your questions should not be leading. Sometimes you may ask something that could be sensitive, communal wise, or something else, or religion, or other things. But you have to be careful. And committee will give you an approval after going through your questionnaires. So that's an important part of any kind of survey. Okay. So we have to do, look at the attributes and levels very carefully. And for that, you have to do a lot of things. You do focus group discussions, not with the participants or your respondents. So you should be doing FGDs somewhere else, not to the same group. So you try to find out what do farmers care about. And then other thing, here we did it, we met a lot of scientists, International Rice Research Institute and other scientists who were actually doing these breeding to understand what do farmers care about. And we found out that GM, they haven't even heard. If I go to Odisha, a village in Odisha, and ask them genetically modified, no point. But we also find out that they were very interested in crop varieties which are short duration. So instead of the full 3 months, if you could produce crop in about maybe less than 4 month period, so in about 90 days, farmers really wanted that because that will give them a window to maybe grow another crop. Or that'll give them some time to go and do work outside their village, migrate and do some work or farm work and earn some income. So this is something that we hadn't thought about it earlier, But after focus group discussions, we found that that's an important attribute and we included it. So now I'll just tell you what are the attributes that we considered in this study and how we did the designing. Okay. So obviously farmers care about yield, productivity. How much, a new seed, how much will be the productivity? But how do you tell productivity? And here comes, novelty and creativeness of researchers, that how do you even present this productivity thing to it? Because it's not just about mean productivity that we're interested in. We are interested in how will this productivity get affected if there is a drought? How will this productivity get affected if there is a severe drought? How will productivity get affected if there is floods or severe floods? So we thought about how to just model our yield variable, and my students who have done microeconomics with me, I do cover concepts like stochastic dominance. So here we used that concept of stochastic dominance when one distribution stochastically dominates another. But of course, I'm not going to use the term stochastic dominance with the farmers. So I'll show you that what we used, but what is the economic theory behind it. So, everything should be grounded in economic theory. You just don't have, randomly you can introduce your attributes. Okay. So this is like about my yield variable, how I'm going to present this yield variable to farmers. So I consider a reference variety, the rice variety that they are growing already. So during our survey, we asked them what is the rice variety that you're growing. And this rice variety gives yield of, just look at the first column. 53 quintals per hectare under normal conditions. But if there is a drought, it'll just drop down to 22. And if there is a severe drought, it'll drop down to 6. So that's the reference variety. So we say that, okay, what is, we find out what is yields under reference variety. And then when we give them another alternative, which I call first order stochastic dominance in my mind, but I'm not going to say that to farmer. And we say that, suppose there is another variety that gives you more under all 3 conditions. Under normal conditions, under drought conditions, and under severe drought conditions. So that's an alternative option. Then the second option is, which I'm calling second order stochastic dominance. It gives you same yield as the reference variety under normal conditions. But if there is a moderate drought, your yield is better. You don't suffer as much. Instead of 22, now you're getting 32. But if there is a severe drought, your yield gets better, but not too much better. Okay. So instead of 6, you're going to get 16. Okay. Then I also give another option in which your yield will be as good as reference variety under normal conditions, but you can see that it will be under moderate drought conditions, the yield will be same as the reference variety, but under severe drought conditions, yield will be better. So this last is more useful if you are expecting a severe drought. Okay, so that's how we present yield to them. Rather than one number, we give them a distribution. Okay. The next attribute, so last class we talked about that there are attributes and each attribute can have levels. So the next attribute we're talking about is submergence tolerance, and it says that for how many days the plant can survive if there is waterlogging, if the plant is submerged in water. And it has 3 levels. One is 0 to 5 days, The second level is that even if there is water up for 10 days, because water will recede. So if it takes up to 10 days to recede, the plant will survive. So it can survive under mild flood conditions. And our third level is if it can survive up to 15 days. And again, these number of days is not something arbitrarily. You talk to scientists and you find out, okay, the reference variety, for how many days can it survive, and then you talk to scientists that, okay, you're developing new variety, and actually during that time a new variety had come which was called submergence 1, and that variety could tolerate waterlogging up to 15 days. So everything has to come from scientific evidence, and it's not that like you can do things whichever way you like. And this is short duration, the duration attribute I was talking about. So in short duration, less than 120 days. Normal crop would be about 135 days. It from planting the seed until the time you harvest it, it takes about 135 days, 4.5 months. Okay. There are some short duration varieties, and there they can give you results within 120 days. Okay, 4 months. And there will be something like medium duration, which is 120 to 135 days. As you can see, it's you can't change things drastically. From 135 days, you can bring it down to 120 days, but you can't say that within 1 month I'll plant and I'll be able to harvest. So again, all this has to come from scientific evidence. Okay. Then I also include an attribute which I'm calling as a seed type, which can take 2 levels. One is that seed can be stored and reused next season. In traditional farming, what do farmers do? Whatever harvest they have, 10% of it or some percent of it, they'll store it and use it as seed next year, and rest they'll sell in the market or consume. Okay. But we also know that there are new seed varieties which cannot be used next year, and you have to pay royalties every year if you want to use them. And genetically modified seeds are one of those. You cannot reuse them. You planted them once. If you want to plant next year, you'll have to buy a fresh set of seeds, because the company which has developed them, that gets royalty. That's how they make money out of it. Since we could not use the word GM, we rephrased it and talked about in terms of whether it can be used next season or it cannot be used next season. And hybrid varieties, so we know that in wheat, most of it, the green revolution brought in hybrid varieties. Okay, and then we chose a number of price levels ranging from 15 to 300 kg. And this was not done as sophisticatedly as we discussed last year. So the way we thought about it was, went to the market, saw that for a conventional rice variety, seed price was about 15, and for hybrid varieties, for the most expensive varieties, prices went up to 250. So we just took a little bit more and made it a 300. Okay, so that's how various attributes and levels for each attribute. Okay, maybe I'll here take a few questions if there are any. Okay, but very briefly, because I want to cover this whole paper. Yes, there are a couple of questions. Yeah. Okay.
Ma'am, I have one question, that is how you came out with that first order stochastic dominance, because you wrote the yield in the sequence, right? First, second and third. So how you came out with that figures of yield in different levels? Did you use some modeling on it, or it was from any scientific community?
Yeah. It is. So we look at the reference variety. Okay?
Okay.
Because for that, we have evidence from the market. What are yields in a normal year? What will be the yields in a drought year? And what will be the yields in a severe drought?
So
Okay?
this
So-
is the yields for a specific variety you are talking about? Like
So the variety which was normally used in Odisha at that time. I also have names in my detailed paper, but yeah. So you go and you survey. They were using one particular conventional variety, and what were the yields that we got from the market data, and then we go to scientists who are developing drought tolerant varieties, and we ask them, okay, what do you expect? How much improvement? It's not like it'll be a drastic improvement, but how much improvement can there be? And that's how we got these yields.
And I have another question on you said about seed type, like for hybrid, you have used hybrid as an instrumental variable for referencing it to GM, right?
Not really instrumental variable, but you can say as a proxy.
But
I mean, it's not an exact proxy or anything, but since we couldn't use GM, so I'm not going to present results saying that it's GM, but still there is a difference in preference. If seed is if you can use it next year, that means you don't have to spend on seed next year. So that's the trade-off: yield versus cost saving next year. That's what we are going to capture here.
but ma'am, because why I had that question of hybrid, because there are many hybrids apart from GM in the market.
Yeah, of course.
There are plenty of hybrids
There
actually.
are plenty. Yeah,
So it's
that's
very
what
hard to-
farmers know. No, I'm not. I'll never, present my results saying that this is valuation for GM. I was telling you the motivation.
Okay.
How we started, but we couldn't find out valuation for GM because it was not possible. But we could find valuation for hybrid.
Okay.
Okay, what's your name?
Sumit
Sumit.
Sutradhar.
Oh, okay. Yeah. Thank you for your questions.
Hi, I'm Tanu. I had one question. You mentioned about consequentiality, where you said that we would actually be telling the respondents about how their responses are going to be kind of narrated to the policymakers. But when I was conducting a survey, I found that once we tell them that how it is going to be translated to the policymakers, like let's say if I was discussing about the public distribution system or something, they would actually try to kind of give me a kind of narrative which is, let's say, they were very pessimistic about policy schemes in that regard. So once we tell them that if we give this narrative to the policymakers, maybe they might not reveal a true picture or something. Did you face this something of this sort?
Okay. Khushi, Adam wants to respond to that. So.
Also, you mentioned this one more question. You mentioned about focused group discussion, and you said that you are taking a different group. In terms of you'll do some this kind of thing discussion with some other group. So in your regard, did you take the discussion with scientists, and how helpful was it to kind of to figure out the actual this thing survey for the farmers?
Okay, thanks Tanu. Adam, yeah, you want to respond?
Thank you for the question. So that is a very good question, something we have not covered. Of course, as let's say that consequentiality is a requirement that economists have come with theoretically. Theoretically, if you don't transmit consequentiality, you cannot say that people are going to be willing to reveal the truth. So remember, the idea is to simulate a market as serious, as realistic as possible, and that is consequentiality. That's why consequentiality is important. The story that you are telling relates to the fact that we don't know whether people are going to be revealing more or less willingness to pay, whether people under consequentiality are going to be saying, oh yeah, I love it because I have a lot of hope that it's going to become a policy, or oh, I don't believe that this is going to become policy if we put it with the policymaker, and then I am going to just pay this. Theoretically, we don't know what is going to be the effect of having something consequential. There is some studies showing that actually it can go both ways. In some contexts, when they have done split samples with and without consequentiality. And they have shown, with consequentiality, people reveal higher willingness to pay. state with higher willingness to pay. In another context, with consequentiality, people state lower willingness to pay. We are right now with some colleagues studying willingness to pay for adaptation in Europe, in 7 countries of Europe. And those people that actually we communicated consequentiality and believe that there was going to be some consequentiality are revealing incredibly high willingness to pay for adaptation. And I say incredibly high because we have been estimated as percentage of their income, and it almost reached 20% of their income, which is difficult to sell and to believe. Those people that didn't believe in the consequentiality were revealing lower willingness to pay. That is more realistic. So, to summarize, this is a great question. Please think on always adding consequentiality and keep up with the literature, because as of today, we still are discussing best ways to phrase consequentiality, and also whether we should have a strong opinion on whether once you express consequentiality, it should deliver higher or lower willingness to pay, or you should have an idea. And right now it's an open question in the methodology. So what you are describing, it happens, and so far the recommendation is still add consequentiality, even if people are a little bit too critical of the possibility. That is the recommendation, even if it decreases the willingness to pay.
Yeah. Any other question? Yeah, Aishwarya.
Ma'am, continuing with what Tanu asked, so you said you have taken scientists as the focus group. So how should we?
No, I never said that.
You've spoken
I'll
to
answer
scientists.
that. I'll answer that. Any other question?
So, ma'am, just how do we select the focus group for a particular experiment? So
Okay.
that's the question.
Yeah. Yes, you can ask.
Thanks.
Thanks,
These
Emina.
attributes like duration, is it mutually exclusive to say flood, submersions and drought resistance, or they are the same varieties?
No, it's that attribute is different from submergence tolerance and drought tolerance.
Means these are normal varieties duration.
Okay, I'll just explain that. Yeah.
Ma'am, for drought tolerance attribute, when we were referring to levels for first order and second order, what was the trade-off for people?
So that'll come in the results part. Right?
Okay.
Yeah. And maybe I can just respond to focus group discussion. Thank you for all the questions. So yeah, it's not that you can do focus group discussions with the scientists. You have to do focus group discussions with farmers, but I'm just saying that I'll show you that we chose 3 districts in Odisha. So for focus group discussions, I can go to another district within Odisha, so that which also experiences similar conditions. So that is where I'll do my focus group discussion. And about attributes. So each attribute we are seeing as a different characteristics of the crop that they're going to. So short duration is another characteristics. Okay, so Pranav, are there any online questions? But maybe I can take that later. Are there any? No? Okay. So I'll just continue. Yeah, I think that was a good discussion, that what are these attributes and what are levels for each attribute. Okay, so yesterday some of you were very curious about how do we do it and what is the theory behind it. So I just put a few slides together for econometric and economic theory behind it. Those of you who are from other disciplines, it's okay, you can skip it, but actually my class is missing today. In the morning half they have classes, so some of them not here, those who had asked those questions. Anyway, they can go through them. So the basic model that we are going to use here is a random utility model, and which says that utility that any individual gets from a particular product, that depends upon, and that can be written as a function of observable attributes of that product and maybe characteristics of the person, which is x, nit, and beta is the coefficient. So xi are vector of attributes, all those attributes that I talked about, they are observable and I can include them, and beta will be the marginal utility of attribute in this form, because if I do del u by del xi, I get beta. And now this epsilon is the unobserved part of the utility, residual, and everything gets subsumed in epsilon, and it will be stochastic in nature. You can also see that utility is something that a researcher cannot observe. So if I do a survey, I cannot observe utility, and we call it a latent variable, something that's there that is guiding the decision, but I cannot observe. As a researcher, what can I observe? I can observe which alternative did they purchase. For a specific alternative, was it 1? Did they purchase it? Did they choose it? Or was it 0? And the economist in me is saying that it's going to be 1 only if I prefer that alternative to all other alternatives that are there. So if I give you 3 choices and a respondent chooses one particular choice I, what do I infer? That the utility that this person is getting from I is larger than utility from other alternatives, alternative B and C. Okay, so that's economic theory behind it, and then we can figure out what is the probability that this person is going to choose alternative I. That probability will be if the utility this person is getting from alternative I is larger than the utility the person gets from any other alternative that's there in the choice set. I can do a little bit of manipulation, and you can see that how this just comes to cumulative distribution function. This is nothing because these are random variables. Epsilons are random variables, and probability that a random variable is less than certain value, that's CDF. So starting from a utility function, I've already come to CDF, and we also now need to assume what is the distribution of epsilon. And if I assume that epsilon is distributed extreme type 1 or Gumbel distribution, then there is a result that the difference between two of these Gumbel distributions is logistically distributed. So you can see that how easily from my utility function I've come to logistic function, and that's why I can use logit models. And in a conditional logit model, probability that an individual is going to choose an alternative I will be simply given by this ratio. And what is this ratio? These are all observables. So I can now estimate this probability, and that's what we're going to do it. Okay, so there were some questions that how do we move from here to here. It's this pretty simple economic theory behind it. Okay, so this is called conditional logit because what I'm going to choose is conditional on the attributes of the product and my own preferences, depending upon maybe how educated I am, what is my income, whether I live in a rural area or urban area. There could be so many things about me. So that's why it's called conditional logit. But conditional logit has two limitations which we talked about, but I'm just repeating here, that it assumes that preferences are homogeneous across all respondents, which is not true in reality, so we'll need to refine it. And it also assumes independence of irrelevant alternatives. And I'll just, it's very simple to see how independence from irrelevant alternatives, because if you take ratio of two probabilities, see, Pni by Pnk. So consider two alternatives I and alternative k, and if you take that ratio, the denominator will get cancelled. Oh, which one? Is it off? Hello? It's not working. Thank you, Kushi. I hope you were able to hear me and everything hasn't gone waste. Okay. So here I was showing you, if you take a ratio of probability of buying alternative I and probability of buying alternative K, the denominators will cancel out, and it's just exponential of the observed part here and the observed part for K. And this is called independence from irrelevant alternatives. What is my preference from other alternatives? That doesn't even feature here. Okay. Right. So we move on to a more sophisticated model, which is a mixed logit model or random parameter logit model. And this model takes care of both those limitations. So here we allow for preferences to vary across individuals, right? I have a different preference, you could have a different preference. My model allows me to do that. And now we don't even need to assume independence from irrelevant alternatives. So this is the model that we'll be estimating most of the times. Okay, and the probability that an individual I is going to choose, individual N is going to choose alternative I will now be given by this expression. Okay, so this is like, these details are for people who want to really learn the econometric theory behind our estimations. Okay, so we need to now describe distributions of all our attributes. We'll normally assume that these coefficients are distributed normally, and we'll keep the coefficient of price to be fixed. That makes it simpler to work out the willingness to pay coefficients. Okay. So this I think I already said that beta i's are marginal utilities. So when I'm going to estimate, estimate marginal utility for alternative I, for attribute I, and similarly I can estimate marginal utility for attribute K. And now you can see that if one of these alternatives is price, if one of the attributes is price, and when I take two ratios, that'll give me marginal willingness to pay. So after my estimations, I just need to take a ratio, and that ratio will give me marginal willingness to pay. That's what we are going to do in both applications. Okay, yeah. This is simply willingness to pay is the ratio. Okay, about the experiment. This experiment was conducted in the months of June and July in 2013 in Odisha. And we are from India, so we all know Odisha is in the eastern part of India, and you can see that it's along the coast. So a lot of monsoon variability it suffers from, and there are often floods. So this is one of the states which suffers from both kind of natural calamities. There'll be floods and there'll also be droughts, and therefore it made sense to do this experiment in Odisha. And also this is a state which primarily grows rice. Rice is the staple crop there, and farmers are interested in rice. And we conducted this experiment in 3 districts of Odisha: Cuttack, Dhenkanal and Jagat Singhpur. And as you can see, this Jagat Singhpur is on the coast. So this is a district that suffers more from floods. And in the interiors, this Dhenkanal, It's again mic is not working. आपका जो mic में बहुत problem हो रहा है. Can you? So should I speak here? I'll speak here. But I'll need the Acha, it's here. Fine. So Dhenkanal is one of the districts that suffers from drought, and Cuttack is a district that suffers from both floods and droughts. So these were the three districts we chose for our experiment, and for our focus group discussion we did somewhere other than these three districts, but with farmers. Okay, so yeah, I mean this is a sampling, etc. So finally we did for 400 rice growing households in these three districts. Attributes I've already explained to you, attributes and levels. So it's just putting everything together. These are so many attributes. 1, 2, 3, 4, 5. We had these 5 attributes, and each attribute had certain levels. And as you can see, levels don't have to be identical across attributes. For price I had 6 or 7 levels. For seed type I had just 2 levels. For other things I had 3 levels. So levels can differ across attributes. If I used a full factorial design, you can see that would mean 324 choices. You just need to multiply all the levels and all the attributes. That's not practical, that's too large. So we did what we learned in the last class, fractional factorial design, and that will bring down my choice sets, maintaining the efficiency. So finally we came up with 36 choice sets, and these 36 choice sets were, hello, can you hear me? Yeah. So these 36 choice sets we further divided into 4 blocks, so that you don't want to present 36 choices to one individual. That'll be like fatigue. Nobody wants to answer. People will say, no, I don't want to take your survey. If you give them 7, 8 or maybe 9, they'll still do it. Okay. So to each farmer we presented 9 of the choice sets, and they had to choose one of the alternatives that we presented to them. Okay, so this is like, this is when we say that you design, this is something you'll have to show us. That's how you present a choice set to a farmer. What does this choice set has? You can see it has 4 options. Usually one has 3 options. I became too ambitious and included 4 options, and then when you do mechanics it becomes very difficult. So I'll not recommend, but anyway, this was my first discrete choice experiment, so I had these. Rice seed A, rice seed B, rice seed C, and you always include an option that no, I don't care about your options, I'm happy with what I'm doing. That's my current seed. Okay, that alternative we always include. Now, you can see this is not an alternative specific experiment, because I'm not giving names to seeds. I'm just calling them A, B and C. Okay. So what is my choice? I have to choose, as a farmer, I have to choose A, B, C or D. One of these I'll have to tick. Okay. What is A? A says that your seed is long duration seed. It will take 135 days for your crop to mature and ready for harvesting. Its yields will be 53 in the normal year, and you can see, the illustration, water tank, full water tank means normal year, normal monsoon. Half water tank means mild drought conditions, and an empty water tank means severe drought conditions. So that's like, you want to illustrate and you want to communicate to them with pictures, and especially if you're doing it with farmers. It also depends whom you're doing the survey with. Okay, so not only water tank, we also had this picture of drought, Okay, then the attribute submergence tolerance, and as you can see here in alternative A, it's 5 to 10 days, and we store water and your crop is under water for 5 to 10 days. Then the attribute whether the grain can be stored and reused as seed next season. So we show them that there is a storehouse and you can store your seed. And in the last alternative, cross means you cannot store it. Okay, so this is just visual interpretation. And then price. So for this, you have to pay 25 per quintal. For option B, you have to pay 300 per quintal. And for option C, you have to pay 220 per quintal. So this is a kind of choice card we are going to show them. And we say that pick up one of these. Okay. So yes, whenever you're doing this, it's important to also have some pictures to show that you actually did it. It's not that you're sitting in Delhi and got it. Okay. So this is like, farmers in Odisha, and towards the right is Achal, my student, and this guy is the enumerator, because all the survey has to be translated into their local language, otherwise they won't even understand. And this is a particular household, we're talking to them. So this is like pictures from actual survey that we done. Okay. In terms of, writing down that equation, UIT, we can write it like this. So you can see that each of the level will enter my equation, and then I can econometrically do my estimations. Okay, how are we doing on time? Okay, I think I can take 5 more minutes and at least complete this paper before we break briefly for tea. I'll skip some of these, but I just want to talk about the results. We did find positive and statistically significant willingness to pay for productivity increasing. That's very obvious. If you tell farmer that your productivity will increase, they'll be willing to pay more for that. But there was also willingness to pay for risk reducing attributes. So this drought tolerant and flood tolerant, that's a risk reducing attribute. In normal years, I don't care whether my seed can tolerate drought or not. If there's no drought, it doesn't have any additional benefit. But I might buy it because I want my risk to be reduced. I don't want, if there is a drought, what? Then I don't want my crop to fail and I'll have no income. So that's why these are called risk reducing attributes. And we found that for Odisha at least, willingness to pay for drought tolerant trade was higher than the submergence tolerant trade. But an interesting result was this. There was considerably high willingness to pay for short duration variety. And there could be a couple of reasons for this. That maybe farmers want to skip droughts, because if your variety is a short duration variety, even if monsoons are delayed, you can still sow your crop. Or maybe between 2 crops, you get a window where you can produce some horticultural crop, which will give you some quick results. Or maybe many of them wanted to do off-farm work. So if you get 1 month, you can go to cities or some other place and do some work. As we know, the agriculture in India is very seasonal. So most labor, during harvesting time, they'll go back to their villages. But during lean periods, they go and work in other places. And then we also find negative valuation if seeds cannot be stored and reused. Obviously, you would like if you can use your seed next year. Okay, but there was a very large heterogeneity in the distribution of this willingness to pay coefficients. Okay. So then we just try to do, farmers. What about farmers in flood-prone regions? What do they prefer? And what do farmers in drought-prone regions prefer? So we said that farmers in the flood prone region, they had a positive willingness to pay for long-term submergence, but they were also, they also valued drought tolerant trade. Okay, this is what, I think Adam has been telling me to do the demand curves. And this is novelty and contribution of the study. Most discrete choice studies, if you see in the literature, are not able to estimate the demand curves. But here, we were able to estimate the demand curve for a seed with particular attribute. So if you see the solid line, that is some seed type A. And this seed type has certain attributes, like its short duration. Do you see the attributes I've written here? So this seed type is short duration. It's inbred and it has first order stochastic dominance attribute. And you can see that the other seed type is medium duration, which is inbred, and it has submergence tolerance for 10 to 15 days. But clearly the demand is much higher for seed A1. And these demand curves are, as we expect in economic theory, downward sloping, monotonically downward sloping. And that provides some external validity here that what we are estimating makes economic sense. It's not like you estimate something. After those estimations, using those estimations, I was able to draw the demand curves. Okay. So another example of this demand curve. So what do you need to do? You specify certain attributes. And then you want to find out what percentage of population is willing to buy it at what price. And that's something which is informative. That's something you can inform to whether scientists, breeders, or policymakers. So again, I have these two seeds, and you can see the solid curve for the same seed attributes. This is percentage of adoption of that A1 seed in the drought prone area. And this broken curve or dashed curve is percentage adoption of the same of that A2 variety in the flood prone area. So not only I can determine overall demand, I can also determine demand in specific regions. And then you know that, okay, so if the price is like about somewhere about 8 to 900 per quintal, then only 20% of the farmers are going to adopt it. But if the price falls to maybe 400, then a large number of farmers are going to adopt it. So suppliers looking at these demand curves can decide whether they're going to which seed variety should they produce, which attributes to include. Okay. Yeah, some highlights that we did find that farmers value reduction in yield variability, and they were willing to sacrifice higher yield under normal conditions. And for India, this drought tolerance trait was more valuable. And maybe that's also something we can relate it to it, because a lot of crop gets damaged due to droughts. So we could find that in our results. But the additional result was also valuation for short duration attribute. But these valuations varied considerably across farmers. I think we can stop here for a quick tea break, maybe 15-minute tea break. There is one online question? Okay, I'll take that. So maybe you can use this mic, read it. I'll use the other one.
Good morning, sir. Sir, you may ask your question.
Is this Nirmal?
Yeah.
Okay. Hello, Dr. Nirmal. Or perhaps you may
Sir,
just repeat it.
Sir, I think your mic is not on. Hello. Yes, sir.
Can you hear me, Parag?
Yeah, now fine.
You may
Right.
just repeat it.
Okay.
I think your mic is not on.
So, Professor Bansal,
My mic is not working?
No, fine. Yeah, sir, you may ask now.
No, he wanted to say something.
so Professor Bansal, thank you very much for that insightful presentation of your work. So, I was kind of wondering when you set the labels for each of the yield varieties. So are these labels kind of fact based, or they are just hypothetical labels that you came up with? Because you see, like I'm not sure. For example, in the choice sheet, let us say that your first variety is FSD, right? So let us suppose that the submergence tolerance for FSD lasts for like 0 to 5 days, right? So I'm not sure whether that is true or not. Just for an example's sake. So in some choice set, so when you do create the choice sets, like out of, let us say, the 36 choice sets, so some choice set, for example, may have this attribute submergence tolerance for FST, which might have a label of, let us say, 5 to 10 days. I'm not sure when you do that, de-efficient design. So if 0 to 5 days is for FST, so in some choice sheet, I'm not sure whether it's possible or not. It comes out to be, it appears to be like, for FST, 5 to 10 days in case of submergence tolerance. So I'm not sure whether you are getting my point or not.
No, I am. Thank you very much for that question. And
Yeah.
so
Yes.
when we are choosing levels, we do it scientifically for each attribute. So that's, we met scientists, we collected data from the market, and those levels were chosen from scientific evidence. But I see your point that when you're combining this, you're asking me that is there a seed which has FSD and long duration, and I think that's what your question is about, right? Is that right? That is it possible to combine submergence tolerance 5 to 10 days with the long duration and the yield that I'm reporting here? Is he able to hear?
Yeah, yes, ma'am.
So is that what you're trying to ask me? Yeah, that I cannot say. That's hypothetical. The combination that turns out after we are doing this, designing these choice sets. So that combination of a seed is available somewhere or not, that I don't know. But when I choose levels of my attributes, that was based on scientific evidence, and from their choices, now I would just want to find out their valuation for different attributes. Do you want to add that to?
Yeah, well, there is.
Probably what I will add is that if there is one of the combinations that for whatever reason the researcher thinks is important to have it there, then we keep it there, right? Like you identify and you say, keeping this one here, this combination, I am going to play with the other ones because they are not that relevant. But in general, once you estimate the willingness to pay or the value for every one of those attributes, you could infer what will be the value of a given combination. And I am going to talk about that in one of the slides in the next session. But basically, whenever you are interested in one of those combinations, you could estimate the value for those combinations coming out from the coefficients that you are going to estimate.